I was also a member of the Friends of Health. Because I gave lectures at the universities, different universities in the United States, you know, where the people said, we want to have education not only in school medicine, but also in the complementary medicine, because it has become more important and so on. And of course, I mean, they say, no, complementary medicine is no medicine, we don't do it. So they asked me to give a lecture there, right? And I, of course, was invited immediately, you know, to saying, oh, I mean, if you have a nuclear physicist, I mean, he really knows if you go further down, you know, you are more and more clever. And we didn't understand what the school medicine does. We don't quite understand it. And we invite these people who will show us, you know. And of course, the opposition was very upset about it. Now, they even get a physicist to give a lecture. I mean, we want actually to do something else. But it was interesting in a way, because I told them about the new physics, and they were very happy who invited me. But after proceeding, they got more and more, I mean, upset about it. Until somebody said, are you still talking about physics? I said, yes. But I mean, that we learned something different. I said, yes. I mean, you learn chemistry and so forth, that is fine. I mean, I'm further down. Yes. And then it turns out that is not as you expected. And then they were pretty upset. But the ones who actually were for complementary medicine, they said, oh, that is exactly what we need, you know. So that's the reason why I had this contact, and I could tell you more about it, why we also got close together with each other. And I mean, he has explained so many things that you can also see if you're a little bit in this region. You can actually talk in a way which is also a little bit makes you happy, you know, because it turns out that the question is what is right and wrong is not valid anymore, right? And that is a thing you can leave it open. I mean, you all know the statement that you say, we experience more than what we can grasp. Yes, everybody says yes, but I mean, that we experience more is that we're still too stupid. So we have to do more research in order that what we experience can be explained, and that is what science wants to do. Now, it turns out that half of the question you ask have no answer. And it has nothing to do with your stupidity, but you have discovered that in the background there is another world which you cannot actually explain without destroying that what you want to say. Now, I always use this as an example to get some idea about it. Somebody comes to you and says, can you explain to me what love is? I said, no, but everybody's talking about it. Yes, everybody's talking about it. But why can't you explain it? Because I cannot explain it because it is something which is connecting and not what is grasping. Right? Yes, but I mean, couldn't you? I said, no. So what shall I do? Open your eyes, go live your life, and you will not ask this question very long. And comes a couple of years, he says, you know what? I fell in love. I said, now explain it to me what it means. I cannot say what it is. So you see that we have in our language the other possibility that we can understand it without really then explaining it in the language which is the one which we can grasp. So that is actually the new field in which modern science is in this case. In fact, what it says, instead of saying, I'm in Wirklichkeit, that is actually a good work. It is not a reality, but it is, we say, it's a potentiality. It is only the infinite possibilities to become matter and become energy forms, right? But it is not as such, so it has an open thing, which means the future cannot be predicted anymore. The future is open, which means that creativity is a possibility, and not only that I imagine, I'm creative, but you can be creative in this way, right? Which has the consequences then. Then when you hear about, I mean, the physicists also like that, you know, that it has a beginning in the universe and so on, and for them it's a Big Bang in the beginning, you know, Big Bang, you know, and nobody knows what the Big Bang is, but that is, so to say, at one moment, you know, all the wisdom from the future that it's in this case there, and you have just to follow. It's not very interesting of being alive, you know, to say, I mean, everything I do is already decided in the 1/1,000,000th of a second, you know. It's not very nice, you know. It is also not the one. They still don't know. But it is, from my point of view, this is not the Big Bang at the beginning, but it bangs all the time. Bangs, bangs, bangs. And who bangs? We all. Everything which is alive bangs, you know. That is, we are in a world which is basically creative. Basically creative. And this, in a way, interested me very much because, and brings me close, actually, to Taoism of the Asian world, Darwinism, which says, there where you walk is your way. Where we have, there is a way, there you have to walk. You know? That we have, with our creativity, have an open mind for that. Now, this is now very important for that, what I want now to be concrete, that I will talk to you about the whole energy problem we actually have. Now, so I really go to something with which I certainly have to use also what I have learned in the background, but which I can also, in a way, explain to you with the normal language of daily life. Because it turns out, from the new theory which you get, which I will stop now, on many nice stories to tell, is when you average over this here, then you see you get the old theory again. But it is basically, it is alive. And it's like this here. It looks like it's not alive, you know. It is not so, because if you look at the molecules, they go around, they're not sitting there and doing nothing. They're very much alive, but then we don't see it, you know. So I have not the trouble like the biologists have, you know. They say, I start with something which is dead, but I make it so complicated that it starts to become alive. So we are totally being alive. We are just so confused, and we look that we're doing something reasonable in this case, and that is not the case. You just have to think about that we have here the life on Earth for 3.5 billion years. It sounds like a long time. Can you imagine that a chemical soup for 3.5 billion years is, after 3.5 billion years, has all this appearance, what we call it's alive. Not only the human beings, but the other one. How in the world can it be that is? It is impossible. It is impossible. You can calculate it. It's so zero, the probability, that you can fill the whole room with zeros in order to express that, and then it's even not right. And the reason is that the non-living has a very bad part, which we never learn in school. Also, it is actually very basic in this case. And that is, it has the statement, in the future, the more likely happens more likely. Isn't that wonderful? That the more likely is more likely? I mean, it is, of course, the more likely is more likely. That is more likely, more likely, huh? Yeah, but it is not without consequence. Look at your desk at the weekends, you know. It's nice. you know, clean and so on. And on Monday you sit down here and then you start working. And then already at noontime it's a pretty mess. In the evening it's a total mess, you know. Now, because there's a tendency that the less likely becomes more likely, and that it doesn't turn around. It doesn't help you if you go early in bed in order to give your desk a chance to be again, you know, cleaned up again. It's not in a way getting the other way. There is no possibility in the old way of thinking that the disorder goes over in an ordered system. But life is in these tendencies, you know, that we have more and more complicated system. These are more and more unlikely to happen, that they do. And I tell you, when we talk about, you know, what the growth of the material growth and the energy growth and all of that kind of thing, there is no growth in this kind except life itself. Life itself, the evolution of life, is actually that something comes up which looks more complicated, which is more complicated as that. And what are actually the conditions in order to do that? So, now, you see, when let me see, yeah. The most important part, I mean, to get on this practical part, which in a way is a crisis at the present for us, where we all try to see a solution, is the statement that the planet Earth is a rather isolated thing, you know, which the matter and the energy is actually there for us to use, but we cannot increase it or make it less. Now, with matter is very clear. Matter will not disappear, but it appears sometimes, and it disappears when it's stretched out and we throw it out. Then iron gets less and less, and copper gets less and less, and all this kind of thing. So we have to go there. But many people do not know that the energy is also so organized that the sun energy which comes in has to be reflected back into space. Otherwise, we would melt and be gas at the end, right? We say, no, I mean, because we use the energy like that, no? The energy is conserved, you know, it doesn't increase and all. But there is, of course, a possibility that part of the energy is captured. Here I have also another picture. You know, the light comes in and it falls down there. It was transferred into heat, and the heat gets energy back into space, and exactly how much is in it gets out, you know. So what we actually need for life is actually energy. And we call that exergy. It is the part of the ordered energy, because, I mean, the unordered energy is just heat, and that is not really useful for that what we actually want to do one or the other, right? That means, in a certain way, you can say the sun is sponsoring us ordered energy, and they are the basis for all the biosystem which we have here. And the biosystem starts with something which is already alive. But then it goes in the direction that it gives this complicated situation which we have now, you know, including the human being and so on. This is actually a sun which gives us that without asking for money, right? If you look at the spectrum, actually, of the sun, it looks like this here, and only a certain part of it, you know, I have the yellow thing underneath, that is the visible life, but it is, the sunlight is to left and to the right. And now, the interesting part is that not all the sunlight which comes in and gets on the Earth's surface, are, so to say, captured and hold there. But most of it becomes heat and goes actually back. But some of them, it turns out, get caught in such a way that it stays there, and then it goes underground and becomes then the source of the fossil fuels, coal, oil and This is captured. Sun energy. But how did they actually do that? And prevent that it becomes heat, which that is immediately off, but really get caught. But it took a long time. It took 500 millions of years to collect all this, what we have fossil fuels, right? In this. So that is from which we actually live. I will indicate just to you what it is called synthesis about. It starts with carbon dioxide and water. And it is, we both have in there, And then there is two frequencies of this spectrum, Only the blue and the red. There's two strips there. They are actually used, and the rest, it's not really there. So the sun gives us energy, much more energy than all of the biosystem actually takes over, right? So if we say we have not enough energy sources, this is not right. There's only a very small part of the sun energy is there. It turns out it is only 1/5000th of the sun energy actually is used for the biosystem from which we actually live here, And when we eat and so on, we know it goes in this way. It's actually a very complicated thing that it is not one process to do it, but I will not go into it because it's quite interesting that it takes actually 40 steps to catch it in such a way, in such a way that glucose is ended up at the end. It is caught chemically and is the basis of all our fossil fuels, because the glucose has no chemical use. It has stored the energy. It has found the way to catch, which was a beam, which was a radiation, and something which lasts millions of years. Right? And we, in 1 million years, do that. Now, it was very dangerous that we discover that, right? Discovering that, said, oh, there is something like this. And we took the approach of a mafia. We steal it. Instead of taking it from the sun, we say, well, anyway, other people can do that. We get it out there. And in such a speed that, of course, taking that out was millions of years it took to be caught. Now, in 1 million, in 1 year, you put it there. Of course, the equilibrium out there between all the plants, there are millions and millions of different plants. They are coexisting, equal age, and don't sit together and say, how do we live next year? No, they don't need that. They have a way of being connected. And that is a very important discovery that we believe that we are actually independent of each other, right? And we sit here on our chairs. We have actually a connection in the background, which have nothing to do with matter and energy. We are connected. There is only one world, only one creation, which is growing, of course, in size, because every creative thing does not give the other way to walk, but a different dimension. So we have something which is is nourished, so to say, by giving more and more of this here and there. And then we come that and dig it out, and of course it cannot really get this balance back which it has to have in its own development. Now, in this in context, it is very important. What is different between the living and the non-living is that the non-living is in a static balance down there. I have my pendulum not along, and I could immediately see it. It goes down like there here, and that's stable. If it's like this here, it is not stable anymore, right? It is the instability which plays a very important role, because the instability is the laws of physics do not work anymore. But we say, oh, just only 1 point. I mean, never mind. And if you give it your computer, he starts calculation, and then suddenly he stops and says, error, 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 right? And then you see that is actually something in the background that the classical physics, I mean, actually not do. And I use actually this as an example that the evolution of the living here is that we have a building which goes higher and higher, in which one is unstable and the other part is also unstable, and if both, in a way, together there, they have the possibility to make something stable on which the next layer we can actually then build. And that is what we mean by when we, in a way, jump around on these things, it will collapse. And that is actually what we see, that we are there, that suddenly there is a shrinkage of diversity because we pull cards out on the bottom, you know, and then jump around because they say, of course, that is the way when you say, all right, you have no chance whatsoever to survive in this case. It's not a sustainability of that time. Sustainability is actually not a very good word for that. You will feel that if you have to convince people, your young people, to say, look, the most important thing is, for your future is not mine, mine is nearly to an end, yeah, is that you know that you see we have sustainability, the ability to sustain. That is not enough. The stability to sustain is that you just lie down on the floor and die, and